Okay, so number 20. I'm going to do these quick. I think these are pretty easy for you, right? You guys know all this trig stuff, fresh in your mind. You knew it before the class even started. Just use the unit circle. So I'm going to go get the unit circle. Okay, so what's the question? Cosine pi over 3. Let's go find it on the unit circle. Pi over 3. Remember, it's cosine sine. So cosine is a half. So we got that. A half plus. Now tangent of 5 pi over 3. 5 pi over 3, right there. You're going to have the unit circle. You get a full sheet of notes on the final. Have I said that clearly? Full sheet, like 8.5 by 11. Normal paper size, both sides. Right? Anything you want, both sides of a full sheet of paper. Have it with you on the final. Or just use your old 4 cards if you want, whatever. Either one's fine if you happen to still have those hanging around. So full sheet of notes, anything you want, both sides. And I would put the unit circle for sure somewhere in the corner. And cosine sine. So tangent is sine over cosine, isn't it? So tangent is going to be minus a half over square root 3 over 2. I did that right? Yeah. No. Sine, minus root 3 over 2 over half. I did that backwards. Try that again. Minus root 3 over 2 over half. We good to there? So now you know what to do. Grab this thing, flip it up. So a half plus minus root 3 over 2 times 2 over 1. These cancel. So it's a half plus negative root 3. I think you're good to there with no problem. Now, I want to make sure at this point you know what to do. So what do we do with a half plus negative root 3? Common denominator. Yeah, in order to add two things like this one's over 1. Just put it over 1. Got to get common denominator, which means multiply top and bottom by 2 for that one. So it's going to be a half plus. Now, what happens when that negative root 3 multiplies the 2? The 2 goes to the front, doesn't it? If that was a root 2, then it would multiply the 3 and be root 6, wouldn't it? If they're both inside roots, then they multiply together inside. But the 2 is not inside a root. He's outside, so he stays outside. Minus 2 root 3 over 2. Now they have the same bottoms, same denominators. Combine them, right? So it's 1 minus 2 root 3 over 2. There it is. It's not there. None of the above. Your favorite answer. None of the above. Yeah?
Can you write it backwards?
2 root 3 plus 1. You can write it negative 2 root 3 plus 1. Yeah, you got to keep the sign on him. Yeah, that's the same answer. It's still not there. Yeah. Yeah, you can always, good question. You can always change the order, right? We all clear on that? You can order never matters, signs in front matter. Right? And just think about numbers. Just think about plain old numbers. Negative 2 plus 3, 3 minus 2, it's 1 either way you do it. Sign in the front, same sign in the front. Yeah, so anytime you want, you can change order as long as you keep the sign in the front. So yeah, good question, good clarification. Either way. Yeah, so I don't want you to get tripped up on the final having the right answer and it looks a little different. You might not grab it. Yeah, so that's a good question, good clarification. That is the same answer. You're right. Good. All right, let's go to 21. Feel free to stop. I'm going to be trying to move fast, but you feel free to stop me. If you So cos theta is 2/5, tan theta is less than 0. Find the sine of theta. So it's one of those, draw the triangle. So first off, we got to figure out which quadrant we're in. Remember how that works? All students take calculus. So they're saying cosine is positive. And tangent, what do they think about tangent? Negative. Tangent's negative. So what quadrant are we in? Yeah, that's where cosine's positive and not everything's positive. Right? Tangent's negative. So we can't be in quadrant 1. So we're in quadrant 4. So quadrant 4, good. So we're in quadrant 4. So let's draw the triangle in quadrant 4. So I'll go into quadrant 4. Now, when you make the triangle, which axis do we go to? Got to go to the x, because reference angles always reference the x-axis, because 0 degrees started at the x-axis. Okay, put the theta there. And now, if that's where theta is, right here, then this side is opposite, this side is adjacent, this side is hypotenuse. SOHCAHTOA. Cosine is adjacent over hypotenuse. Adjacent, hypotenuse. So this side is 2, hypotenuse is 5. So how do I find the opposite side, the other side? the Pythag. So I do the Pythag. A squared plus b squared is c squared. So that's 2 squared plus b squared is 5 squared, right? The hypotenuse is the c. That's 4 plus b squared is 25. Subtract 4. B squared is 21. Root of 21. So that side's root 21. Now we're ready to answer their question. They're saying, what is the sine of theta? Now, I really should be more careful with the pluses and the minuses. I'm just ignoring it, and I'll fix it at the end, but I'll show both ways. Sine of theta, sine is opposite over hypotenuse. So that's going to be root 21 over 5. Root 21 over 5. And then, they got negative. So it must be none of the above. No, I'm messing up, huh? So watch out. Again, you don't want to do all that good work and mess up at the end. So let's make sure the sign is right. How do we know what the sign is? All students take calculus. So I'm in the fourth quadrant where cosine is positive and his reciprocal, his upside down, secant. But the other 4 trig functions are negative. So sine has got to be negative. So B is the right answer. Or I could have just been more careful. This is plus, this is minus, isn't it? Because it's right and down. So that had to be minus. So that's why it's technically minus root 21 over 5. You know all that, right? Questions on that? We just had that a couple weeks ago. All right, a little bit. Let me rewrite it here. So 22 is y equals x squared minus 13. And x squared plus y squared is 25. Okay, yeah, want me to solve these two? Remember we did this and there's like an easy way and a hard way? I don't know if you remember this one in particular. So the hard way would be to grab that whole top and to grab all of this and plug it in for y. I mean, it'll work, but it's just a lot of work. It's kind of hard. What turns out to be easier, do you remember this particular one? It was on the practice exam number 4 that you just did. Let me rewrite it here. It's easier. Remember what we did that made it easier? Yeah, jump this 13 over and get y plus 13 is x squared, and then plug in for x squared instead. It just makes it easier. Either way is okay. You know, either way is going to work. You're basically going to plug one into the other. It'll work either way, but this is easier. So this will be y plus 13, right? That's what x squared is. Y plus 13 plus y squared is 25. And I don't need to square it because this is x squared. It's already squared, right? Y plus 13 is what x equals already squared. So x already squared is y plus 13. It'd be wrong to square again. Okay, so now I got to solve that equation. How do you solve a y squared? Get a 0, right? You guys are pros at this now. Subtract 25 from both sides. So we get y squared plus y minus 12 equals 0. And then we factor. Y plus 4, y minus 3 is 0. Right? Factors, right? What two numbers multiply to be minus 12, add to be plus 1, plus 4 minus 3. And so then you set each one to 0. You know the drill. It's going to be negative 4 and positive 3. When you set each one to 0, right? In fact, let me move it up a little bit. Now, those are each y values. Negative 4, positive 3. We've got to get an x that's going with each of those. How do we do that? How do we get the x? Going to plug in, aren't we? Plug in like to this one. So x squared is y plus 13. So x squared is y, plug in, negative 4 plus 13. X squared is 9?
It's just asking for a y.
Oh, good. All right, we're done. Thanks. Thanks, Cam. I was going on and on and on. We're done. Minus 4, 3. Done. No need for x. Questions on that one? Remember that one? We good? All right, I'm going to move on if you're good. This is part 1 still. There will be one 3x3 on part 1. Probably. I don't know. There's not everything. There's only 35, and this is 50, so maybe it's one of the ones I skipped. I don't really know. So let me just rewrite it. X plus y plus z is negative 8. And x minus y plus 4z. Y plus y is 5. And 2x plus y plus z. 12, negative 12. Okay, so there we go. There's the 3 equations, 3 letters. Yeah. Here, it's questions 1 through 23. This is the end of it. Questions 1 to 23 are part 1, no calculator. The rest are part 2, graphics. So if you're wondering what kind of things, it's exactly questions 1 through 23 that are part 1. I think it says it if you print this thing out from the Math Excel homepage. It says that's where it gives the other information. So anyway, yeah, good question. All right, so how do we solve this thing? Got to get stuff to cancel, don't we? So like, see how plus y and minus y, if we add those up, they'll cancel. And then we're also going to do the bottom 2 to cancel. So let me do that. So I'm going to bring this over here. So x plus y plus z is minus 8. X minus y plus 4z is 5. Add those up. 1x, 1x, 2x. See how the y's cancel there? So here, let me rewrite this. So 2x, the y's cancel. 1z and 4z. 5z, minus 8 and 5, minus 3. So there's that one. So what did we do? We got rid of y. So what you do when you have 3 equations, 3 letters, if you're not allowed to use your graphic calculator, because that'd be way easier, but 3 equations, 3 letters by hand, is you get one letter to drop out. It doesn't matter which letter. You can get rid of x from all 3 of them, get rid of y, get rid of z. It doesn't matter. Get rid of one of the letters, whatever looks easiest, from all 3 equations. So I'm getting rid of y because those just looked easy. Same thing here. I'm going to bring these 2 down. X minus y plus 4z is 5. 2x plus y plus z is minus 12. Add them up. 1x and 3x, 1x and 2x is 3x. The y's cancel again. 4z and 1z is 5z. And this is minus 7. So now we have 2 equations that only have x and z on that. Yeah?
Since we're only solving for x, can't we just multiply the first equation by -1 and then just add it to the third equation? That would be x equals -4.
Yeah, that'd be nice. Good observation. That'd be even easier. It doesn't usually go that way, but yeah. On this one, way to go. Really good observation. Yep. That'd be a lot quicker than what I'm doing. Yeah. Usually they won't lend themselves to such nice things, so I'm kind of doing it this way, but yeah, good observation. All right, so I'm going to finish this up. Let's bring them together. Bring this one on down. 2x plus 5z is -3. So what? Now I want to finish eliminating stuff. So what am I going to eliminate now? The z, the 5z. Since they're matched up, that'd be easy. Just multiply. Got to make them opposites. So make one of them a -5z. It doesn't matter which one. I'll just multiply a negative through the bottom one, I guess, which makes this plus, doesn't it? See what I did there? I just multiplied negative all the way through this bottom one, changing all the signs, so that I could make these guys cancel. 5z and minus 5z. 3x minus 2x is 1x. The z's cancel. Minus 7 and plus 3 is -4. So x is -4. Is that all they want, x? So we're done. That good? Remember 3x3s? Questions on that one? All good? Is that coming together for you? So let me try to help with the picture. So basically what they're saying, did you catch what they're saying? Is you got this really tall tower, and the The tower is 210 feet. So that's 210 feet. And you're attaching a guy wire 6 feet from the top. So if this is the tip top, you're going down 6 feet from that, huh? This gap here, well, over here. This gap here is 6 feet. And the wire's going from there down to the, mine got a little shaky there, but down to the ground. Is that making sense, what they're saying? So then how far is this?
204.
Yeah, 204, because it's, take away 6, huh? Is that good? That's a lot of the battles, getting that picture right. Good. And so then they're saying 23 degrees, and they're saying what do they want? How long should the wire be? So they want x, the wire. They want to know the length of the wire. So they want to know the length of the wire. And so, how are we going to find the length of that wire? We're going to use one of the, so there's a right angle, right, assuming that tower is built straight up. It's not the leaning tower of Pisa or something. It's straight up. So we got to find the length of that wire. What trig relationship from the perspective of the 23-degree angle? This side is opposite. This is adjacent. This is hypotenuse, huh? So think about SOHCAHTOA. You getting it? You remember how to do these trig things? So using SOHCAHTOA, what two sides am I going to use? 204 and the x. So that's opposite and hypotenuse. So what trig relationship? Function, sign. Sine's opposite over hypotenuse. See how I determine that? So the sine of 23 degrees is opposite 204 over x. So we use the 204, not the 210, because the 204 is the height up to where the wire is attached. It's the height of the wire triangle. Is this okay? It's making sense? Remember all this? So now solve for x. How do you solve this equation for x? You just put this over 1 and go diagonal, just cross multiply. X sine 23 is 1 times 204. Last step to get x alone. Divide by the sine of 23. Hit the buttons on your calculator. Whatever the calculator says. Make sure you're in the right mode. It'd be a bummer to be in the wrong mode on some of these questions. Double check your mode. We're in degrees. This says 23 degrees, so make sure you're in degree mode. And I'm getting 522.10. Yeah, there it is. A. Questions? Is that okay? All right, I'll keep. So on this one, they're giving us that the little a is 8, so this side is 8. The little b is 3, that side's 3. They want us to find all the other stuff. So we could start by finding c. That would just be the Pythag. So that's pretty easy. I'll just jump in there. A squared plus b squared is c squared. I think these ones are pretty easy for y'all. What's that, 64? Plus 9. So it's the square root of 73, which, I don't know what that is. Is that the 8.54? Okay, so right away I'm like, hey, it's one of these 8.54s, probably. It could be none of the above. It's probably one of those. So now, to be sure, though, which one it is, I got to find one of those two angles, either the capital A or the capital B. It doesn't really matter which one. So let's go for capital A, say. Oh, yeah, and here's A up here. You could do B, it doesn't matter. I'm just going up to where A is. So if I'm going to try to use my calculator to find capital A, how am I going to do it? What trig relationship? So from A's perspective, this is the opposite side, the adjacent side, and the hypotenuse. So what two sides do you want to use? Yeah, the 8 and the 3, because they are not rounded numbers. Remember, you don't want to use rounded numbers. So use the 8 and the 3. So that's opposite and adjacent. Remember, so katoa. So what is opposite and adjacent? Tangent. So tangent of capital A, of angle A up here, is opposite over adjacent. So it's 8 over 3, isn't it? Good. Now, how do I find the A, the angle A?
The inverse of tan.
Yeah, you getting the hang of that? I can't divide by tan, right? We talked about that a little bit. So whenever you have a function, natural log, e to the x, sine, cosine, tangent, those are all functions. The way you get rid of them is inverse function, isn't it? So we get rid of that with inverse function. So we do inverse tangent, and these cancel. So capital A is inverse tangent of 8/3. Hit the buttons on your calculator. Make sure you're in degree mode because all the answers are degrees. So inverse tangent of 8/3. 69.44 degrees. Yeah. So answer A is looking good. You could go on and find B. Just subtract from 180, right? B is going to be 180 minus A. So
Isn't 90 minus A?
oh, 90. Just kidding. 90, yes. So, I'm getting 20.56. Yep, yeah. A's right. There it is. Good questions on that one? All right. So remember, so there will be a absolute value greater, absolute value less on the final exam. Remember, we had a certain way we dealt with that. Thinking about that. So remember, I reasoned out with you about what absolute value means. I just said, hey, think about what if I just, let me just go to fresh screen for a second. What if I just said, hey, absolute value of some number is greater than or equal to 2. Just think with me, real life for a minute. Just set aside all math rules and whatever. What could you put in there that would make that true? What numbers, their absolute value, will come out bigger than or equal to 2? 2, 3, 4, all the numbers 2 are bigger, right? But what else? Yeah, -2, -3, or smaller, huh? Because like you put in like -3, the absolute value would make it +3, and that would be bigger than 2, wouldn't it? So it's really tiny numbers and really big numbers, isn't it? So you would need to say that it's any numbers bigger than or equal to 2 or smaller than or equal to -2, right? This is bigger than or equal to 2, and this is smaller than or equal to -2, isn't it? See that logically? So that's not true just for x. That means you could just write in general, you could just make a general statement here, that anything you have inside, instead of just x, it's in general true thinking, you could just say instead of x, you could just say whatever the inside was, and same thing over here, whatever the inside was, like that. Does that make sense logically? And the 2 could be any number. Now, vice versa, if instead we had the absolute value of x less than or equal to 2. So let's think logically about what you could put in there for x to make that work, to make that true. So what numbers absolute value comes out 2 or smaller? 0, 1, or 2, of course, right? But what about the negatives? -1 and -2, huh? Any of those, like -1, absolute value is +1, less than 2. Right? Not -3. If you did -3, that wouldn't work because the absolute value would be +3, and that's not less than 2. Huh? So you seeing what I'm seeing? So in other words, what are these numbers? These are all the numbers that are between -2 and +2, like that. aren't they? So then, make that same statement, but just make it now, instead of saying x, say inside. Whatever you have inside. It's the same thinking. That has to be between the negative and the positive, doesn't it? So those are the two forms we use, because that's what's true. So coming back here then, so again, if we have absolute value of some inside greater than or equal to a number, we take off the absolute values, right? Right. You say this has no more absolute value. These have no more absolute values. So I'm figuring out how to remove the absolute value signs, aren't we? That's what we're doing. We're thinking through how to correctly remove the absolute values. So the inside is greater than or equal to the positive of the number, or the inside is less than or equal to the negative of the number. Or if it's absolute value inside less than or equal to a number, then that's where you go negative, inside, positive. So those are the two you want to have on your full sheet of notes. I'd encourage you to be making that even right now. Start throwing things on your study sheet for the final. Those would be two good things to have. How you handle absolute value greater and how you handle absolute value less. At least how you do the first step, which is the most important step, in removing the absolute values, right? Notice I've removed the absolute values. There's no absolute values. Okay, so let's do this. Now, this one says greater, but it's the same thing, greater than or equal. That doesn't matter. That's all the same. So absolute value greater. So is that case 1 or case 2? That's case 1, isn't it? Absolute value greater. So that means, what do you do for greater? You take the inside greater than the positive, greater than positive 3, or, bless you, take the inside less than the negative 3. Positive 3, negative 3. No more absolute values. I removed them. That's what that absolute value statement means. It means those two cases, doesn't it? Okay, so now let's just solve these things. So subtract 2. 5x is less than 1, divide by 5. X is less than 1/5. Subtract 2. 5x is less than minus 5, divide by 5. Oh, did I flip the sign? Look at this. What did I do over here? This should have stayed greater, huh? Sorry. And x is less than minus 1. There we go. Greater than 1/5 or less than minus 1. That's what they want here, right? Oh, they have intervals. Okay. How can we write those as intervals? Let's go ahead and put them on a number line. So put them on a number line. X is greater than 1/5. So that would be 1/5 greater, shaded to the right, huh? To infinity. And then less than negative 1. So negative 1 less to negative infinity. So this one goes there. This one goes there. Everybody good there? So how do we say this interval then? Negative infinity, negative 1, united with 1/5 infinity. Questions on that?
In this case, would it be none of the above because it says
I don't know. Isn't it B? Am I thinking wrong? Oh, yeah, or means U. Yeah, good question. Yeah, the U is the same as the or. U is exactly the same as the or. It just means unite them, this or that, united together. Or U is the same thing. So it's B. Good? Should we try 27? Absolute value of x plus 2 plus 9. less than or equal to 13? All right, so what do we do first on this one? Do you realize we got to get rid of that 9 first off? All that reasoning I did, if you look back here, see how the absolute value is alone before or let's go back here. See how the template, the model, the setup I gave you has the absolute value alone before you remove it and do these two things, or this one, same thing, it's alone. So that means you got to fit the model. Do you see how math science formulas work? You get a formula, but if they give you a problem that doesn't match the formula, you got to make it look like the formula first, then you use the formula, or the model, or the template, right? So see, the model has the absolute value with nothing outside the absolute value on his same side. He's alone on his side, right? So I've got to fit that format before I use it. So that means I got to get rid of that 9. So get rid of that 9. So then that becomes absolute value x plus 2 less than or equal to 4. Now it's ready to go. Now it fits the model, and I can use the formula. What's it say? It says if you have absolute value of inside less than or equal to a number, you just go negative number, positive number. A compound statement, a 3-part inequality. It's a little different than the other one, right? So let me do that. That's going to be then negative 4, x plus 2, positive 4. So it's a little different, right? Notice both these have a negative version and a positive version, a negative version and a positive version, but they set them up a little different. So there we go. That was the most important step. I removed the absolute values. So now I've got to get x alone, so what do I do? Subtract 2. You do all three, huh? When you have a compound inequality, whatever you do to one part, you do to all three. So what do we got then? Minus 6. These cancel. And this is 2. There we go. So that, on a number line, that means from negative 6 to positive 2. The x is the shading between negative 6 and positive 2. So our final answer, negative 6 to positive 2 brackets. There we go. We good? Questions I can answer? And we're going to fold it up into a box that holds volume. Okay, so they're saying, they want me to basically find x. Find x that produces maximum volume. Find x to produce maximum volume. So how do we do this? Well, let's write a volume statement. What is the volume of a box?
Length times width times height.
Yeah, it's 3-dimensional, huh? Length times width times height. So the volume of a 3D box is length, width, height. Length times width times height. Okay. So can you see that in here is going to be the new base after the corners are all folded up? You with me on that? This will be the width from there to there. This will be the length. From there to there is the length. And the height will just be x. It's just folded up. All right, so how do we find that width? Notice that width is inner edge to inner edge. We already know right up here that 25 is outer edge to outer edge. So how far is it inner edge to inner edge?
25 minus 2x.
Yeah, this must be 25 minus 2x. Right? Remember that when we did that? Because outer edge to outer edge is 25. Back up x, and you have inner edge to inner edge, don't you? Back up 2x. And then the same thing for the length. If we're looking at this thing saying top to bottom, outer edge to outer edge is 13, then inner edge to inner edge length must be 13 minus 2x. right? Because it's, again, outer edge to outer edge, 13, back up x, inner to inner, 13 minus 2x. So put that in for L, put this in for W. So volume equals 13 minus 2x times 25 minus 2x. And what's the height? Just x. Everybody see that the height is just x. Because as you take this, you're cutting the four corners out of this flat piece of cardboard or piece of steel or whatever it is. You're cutting the four corners out and then folding it up to be a box. So when you cut out these four corners and you fold this up, that x becomes height, doesn't it? When it folds up. That becomes the height. So there's our volume equation. Now, what am I supposed to do with it? I don't have to FOIL it or gather like terms. You don't have to do any of that. Why? Because look at the answers. They just want the final answer for x. I'm supposed to do what? Find maximum. So how can you find max volume? Graph it and find the maximum. Yeah, this is on the calculator. It even says right here, graph. Use the calculator to graph and find the maximum. Yeah. So put this in for y1. You'll have your calculators. Let's do this one real quick. 13 minus, we've done it before, I think. So put that in for y1 to your calculator, graph it, and then find the maximum. So I'm going to go y1 equals, what was it, 13 minus 2x? And it was 25 minus 2x. So that's volume. And when I graphed it, so I made my window just the normal negative 10, positive 10, negative 10, positive 10. And I got a crazy graph. I got just like a straight line. And so what do you do when you get something crazy on your screen? You go second table and you take a look at the x, y values that the calculator is using. So when you look at the table and these numbers are about 400, then go back to your window and make your y max be, I don't know, like 500 or something. And then graph it again. And you just keep fiddling with it till you get something good. So when you graph again, you get a max. So now we just find that maximum. We hit second, calc, max, and you have to go left. Remember, left edge, right edge, enter for the guess. It wants left edge, right edge, guess. You have to go a little bit left of it, hit enter, go a little bit right of it, hit enter, and then just hit enter the third time. And you'll find it. So I got x equals 2.72. Was that one of those answers? There it is, answer C. We good on that? Remember that? Okay with all those steps? Second table, that's the key. Find where the y max is, change your y max. Graph it again. All right. Okay, so remember, how do we find, we got to remember the distance formula. Do you remember the distance formula between any 2 points? Nobody remembers the distance formula?
D equals square root of x1 minus x2 squared plus y1 minus y2.
Right. Square root of x1, yeah, there it is right there. Square root of x1 minus x2 squared plus y1 minus y2 squared. Definitely have that on your note card for the final. Can I just do, it's worth 2 seconds of a derivation. I just want to, you've seen it before. This is the kind of stuff I want to give you. More, if you can know where it comes from, then you don't have to memorize it. Right? Just think about why that's the case. If you have like some point here and some point there, and this point is x1, y1, and this point is x2, y2, then that formula just comes from making a right triangle between them. This is the distance, right, between those 2 points. And so if this point is over x1 and this point is over x2, what's the distance? How long is this line on the bottom of the triangle? x2 minus x1, right? If this is 7 and this is 2, Isn't there 5 between them, for example? Sometimes see how I just plug in numbers and I think better? I think we all do. If you're looking at some formula thing you're not sure, just put in a number. Go, oh yeah, just 7 minus 2, it's 5. So it's just x2 minus x1. That's how long the bottom is. And then how high is this part? Well, how high is this point? y1. How high is this point? y2. So this is y2 minus y1, isn't it? And so then you just do the Pythag, right? This squared plus this squared is this squared. So distance squared is x2 minus x1 squared plus y2 minus y1 squared. And then you know what to do? Square root it. Square root it. That's how they got the distance formula. And the order here, x1 minus x2 squared, that's going to be the same thing. Why? Stick in numbers again. Think with me about it. If you go 5 minus 3 and then you square it, is that any different than 3 minus 5 and then squaring it? This is 2 squared. This is minus 2 squared. See how it comes out 4 either way? See, when you're subtracting two things, you change the order, it just changes the sign, and then you square it, it's positive anyway. So that's why I'm saying this way or that way is going to make no difference. So that's where that formula comes from. That's just Pythag. All right, so there's the distance formula. You don't have to know that, though. Just write it on your full sheet of notes. Okay, so now what do I plug into that distance formula? The two x values, any order. Remember, the order doesn't matter at all, as we established. So x and 7, how about? The two y values, any order. Y minus 1. Good to there? But now, when we look at the answers, see how they're all just a bunch of x answers, no y anywhere? So I'm going to have to get rid of y. So how am I going to get rid of y? Yeah, plug in what they gave you. And I didn't write that down. What did they give me? Oh, I can't see it. Y equals 2x plus 5. There it is. So it's y equals 2x plus. So grab that and plug it in for y. It's easier to plug in right now instead of waiting till after you square, because that would be a lot harder. So distance will be the square root of x minus 7 squared plus, and what is y? 2x plus 5. And the minus 1 is still there squared. Be good. And then that'll become x minus 7 squared. This will be 2x plus 4 squared, won't it? 5 minus 1. And now just square both those. Okay, if I just save some time here. And just square them out real quick. Because I know you can all do this. This will be x squared minus 14x plus 49. The other one is going to be 4x squared. What's it going to be? 8 and 8, 16? 16x plus 16. And so then gather like terms. So x squared and 4x squared. 5x squared minus 14x plus 16 is plus 2. 49 and 16, what's that? 65? So there we go. Answer B. Is it B?
Yes, it's B.
I still remember.
No, it's...
Oh, I don't remember then. Oh, yeah, I thought I remembered I did. We good there? So just distance formula. Have this on your study sheet for the final. Plug in the 2 points and then plug in y in the place of y. Just FOIL and gather like terms. Good there? Questions on that one? Here we go. So for sure, again, for sure this is on the final. This is a for sure one. It'll be on the final because it's what you're going to need in Math 5A. It's like almost the first thing you'll do in Math 5A is you'll do a bunch of these difference quotients. So, okay. Remember how this works? We just plug x plus h in for x in the function. So we get x plus h squared plus 6 times x plus h plus 7 minus, and then f of x. X squared plus 6x plus 7 all over h. Does that make sense what I just did? So, right here, this is the f of x plus h. this is the f of x. See that? See how I just took our function, x squared plus 6x plus 7. I plugged in x plus h, x plus h. The two places there was an x. And then subtracted the whole f of x. All over h. And so now let's FOIL things out. So if you FOIL this out, you're going to get x squared plus 2xh plus h squared, and then the 6 we distribute, plus 6h, plus 6x plus 6h plus 7, and then I'm going to let this minus distribute, minus x squared minus 6x minus 7, all over h. Remember what's supposed to cancel out? All non-h terms will cancel. So if they don't, you did something wrong. All the terms that are missing an h will cancel. So like x squared, I can just cancel them right now. He better cancel or I messed up. Sure enough, look at that. Any term that doesn't have an h, so remember this when you start calculus, when you do these different, you do a bunch of these difference quotients. Whenever you're doing this thing, this is called the difference quotient because it's a difference on the top of subtraction and it's a big old fraction, a quotient. It's the subtraction fraction. It's the difference quotient. So all the non-h terms should cancel. So 6x, he doesn't have an h. He better cancel. He does. 7, he doesn't have an h. He better cancel. He does. See how all the parts not having an h canceled? So then what are we left with? 2xh plus h squared plus 6h all over h. And now what do we do? You can cancel or factor. If you want to just factor an h out of all of them. And then it cancels like that. So it's just 2x plus h plus 6. There it is. You'll do a bunch of those in calculus right in the beginning. And then never again after the first, 3 weeks. That good? So practice that. Be on the final for sure. Okay, so try that one. This one is, there's nothing really to do, but it doesn't make it easy necessarily. You got to basically speak their language. You got to read the graph. So it says f of x is 6. F of x, remember what you plug in is x, obviously that's x. What comes out is y. So they're basically saying go to the graph, find the point that has a y value of 6. This is 2, 4, 6, 8. So y value 6. Looks like there's a couple of them. Right here and right here. Both those points have a y value 6, don't they? So, and they're saying what is the x value that goes with that? I don't know. Oh, and here. That's the one they want. -10. There were some other ones, but the one they said for which of the following x's? Yeah, for this x at x is -10, the function's at a height of 6, isn't it? This is the point. Back 10, up 6. X is -10 when y is 6. Y is 6. Is that okay? See how I did that? I just looked and I said, okay, what you plug in is x, what comes out is y. They're saying y is 6. I drew a line at 6, found 3 points, and this is the one they're listing. Yeah?
Those two really aren't points on the graph, are they? Because the graph's already stating the points that it has graphed out.
Do you mean these raised dots?
Yeah.
Yeah, those are just highlighted, but everything on the graph is really a point. I don't know exactly why they're doing those specific dots, honestly. It's just for visual, but everything on a graph is a point on the graph. Yeah, it's almost confusing the way they're putting certain dots. Yeah. Oh, I guess it's all these points, huh? Is that what it is? I don't know. I don't know what they're doing. Yeah, but anything that's up 6, all these are points that could be the answer. X is -10. Otherwise, things work. So basically it says the graph is going to be this function when x is less than 1, and the graph is going to be this function when x is greater than or equal to 1. So maybe let's start with that part. That part looks easy. And f is y, you know. So the y value is simply going to be negative 2, level at a height of negative 2, when x is greater than or equal to 1. So like that looks right. That looks right. The other two are wrong.
B doesn't.
Right, B's got another problem.
It's got greater than or equal.
Right, I'm with you. But let's first focus on the main idea. Everybody with me on the main idea? There's got to be a level piece from x equals positive 1 and to the right, right? Greater than or equal to 1. That's to the right of 1. There's got to be a level piece that's at a height of negative 2. Y's got to be steady negative 2. Yeah, and so what Dylan's saying is correct. If you look even closer, there has to be a solid dot. This is wrong to have an open dot there because it's greater than or equal to 1. Right on the money. So the answer's got to be A. We're done. I don't even need to look at the left side. There's not an E here either. Isn't that nice? There's not a none of the above. I mean, there's over here, but don't grab it. There's not showing me an E option. That's a sucker option. We good? That makes sense? How we determine that? So we don't even need to mess with this left side. It's got to be right. You could do slope and stuff. Yeah, it is right. This line, if you see it, its slope is right. It goes from here to here. Is an easy way to see. Up 3 over 3. See that? So the slope indeed is 1, which is right here. 1. And the y-intercept is 3. Hits it up 3. Yeah, it's right. It's right. We've done this problem a couple times. We did it in the homework. We did it in the practice exam. Here we are, take 3. So maybe if it didn't sink in really well before, it'll make more sense now. So we're talking about a rectangular area adjacent to a river. So we've got this river, and we've got this rectangle we're building next to the river. And let's go through the words, what they're saying. Specifically, notice they say, let x be the length of one of the sides perpendicular to the river. Perpendicular means hits like a T, right? So this is x and this is x, is what they're saying. They said it's one of the sides, but they're the same, of course, so it's both of the sides perpendicular to the river. And the other side, I'm just going to call it y. You can call it anything you want. But they specifically told me where to put x. The sides hitting the river at 90 degrees, perpendicular to the river. Okay? The fencing for the other two sides is $7 a foot. And the fencing for the side parallel to the river, this is the side parallel to the river. Runs the same direction as the river. Right? That's parallel. This fencing is $4 a foot. The other two are $7 per foot. Per foot. And this is per foot. And then it says there's 4 corner posts, $20 each. 20, 20, 20, 20. So, and they want, write a cost function. So what's the cost of building this pin? Well, first off, we have the 4 corner posts. 4 times 20, $80. Plus, now we have the top. How much is that top going to cost? 7x, right? Because it's x feet. It's x feet at $7 per foot. And the bottom is also 7x. And the right side? 4y, because it's y feet at $4 per foot. So clean that up. That's 80 plus 14x plus 4y. But all the formulas, notice, all the answers have just x. They don't have y. Remember how these work? So we've got to somehow plug in for this y and substitute in because we want only x. How are we going to do that? Yeah, there's one other formula that they're speaking of in this problem, and it's area. Yeah, they're talking about area right somewhere right there. Area is 2,000 square feet. So what is the area of a rectangle, like space in the middle? That's area, right? Of a rectangle. What's the area formula for a rectangle? Length times one side times the other. Length, width, base height, whatever you want to call them. Just one side times the other. The area is 2,000. Now, what are the two sides, length and width? Well, x and y. Don't confuse the money here. It's not the 4 and the 7. We're just talking length, not money right now. So the length is just x and the length is y. We're not doing money right now. So that is just x times y. So there's our other formula. Remember, these kind always have two formulas. Going to use this one to plug into that one. Right? So we're going to solve for y and plug in right here. Because the cost one is still our main one. That's where our answer is going to come from. But we're now going to plug into it from the area formula. So divide by x. So y is 2,000 over x. Plug that in right there. So we get 80 plus 14x plus 4. Whoops, getting a little sloppy there. 80 plus 14x plus 4 times. And what is y? 2,000 over x. Is that good to there? We can do a little more cleanup. I mean, that's pretty much it. So 80 plus 14x. Where's that 4 go? Yeah, it's 4 over 1. Goes to the top. 8,000 over x. There we go. Oh, it's none of the above, yeah. That one is a little bit disturbing, isn't it? After all that work. None of the above. All right. We good there? Sorry, that one's terrible. Make more sense this time? That's how it always was for me in these hard classes. Second or third time, I'd be like, okay, now I get it. Inverse, what's first step? Switch x and y. Flip them, invert them, however you want to say that, right. Switch x and y, step 2, solve for y, right? That's all we got to do. So where's the y? F of x. That's your y, huh? So swap x and y. So y's become x's, x's become y's. So then we get x over here and minus 8y plus 6 over minus 9y minus 6. So we swap x's and y's like that. And now, what do we do to solve? So that's step 1. Now we need to solve for y. How do we solve for y? Over 1, right? Diagonal, diagonal. When we have a fraction on one side, whole number, whole letter on the other. Put it over 1, cross multiply. So x times minus 9y minus 6 is 1 times minus 8y plus 6. Distribute. Minus 9xy minus 6x. Distribute. Minus 8y plus 6. So now we're trying to solve for y. Trying to solve for y. But y is in 2 locations, isn't it? Y is in 2 locations. So what do we do about y in 2 locations? Get them on the side. Yeah, we've done that a couple times, huh? So yeah. So y is in 2 places. Remember that? Step 1, get them on the same side. And then factor out the y. Yeah, get them on the same side, factor out the y. So grab this y and jump it here. Grab this x and jump it there. So we'll have minus 9xy plus 8y is 6x plus 6. And then factor out the y. And last step, divide. There it is. There is the inverse function. Now remember, they could make it look different. I don't want you to be fooled. The publishers that make up those multiple choice options, sometimes they just solve the problem a different way so it comes out looking different. How would you recognize? Remember that if you get an answer to something like this on the test, and none of the answers look the same, before you circle none of the above, of course it might be none of the above, but check. Remember what you could do to check is just multiply top and bottom by -1. Sometimes that's how you'll see the other look. So if I'll say or minus 6x minus 6 over 9x minus 8. That's the same answer. Would you recognize that as the same answer? See how the top and bottom were just multiplied by -1? See how both became negative and positive negative? Just changed all the signs. So if they just change all the signs, top and bottom, that's the same answer really. Because they happened to just solve it a different way. So it just came out looking that way. And I want you to be able to get those points in that situation. Is that good? So that's the same answer. How are we doing? We good? Questions on that? Either one of those. So grab either one of those. What this means? Remember function, it just means f of g of x like that. Remember it means one of them into the other. I think I said toaster inside your refrigerator. I'll give you a way to think about it. You're plugging one function into the other. So in this case, it's g inside of f. So you grab all of g, you just pop it in right there, right? So what do you get? And then you get 7 over 4 over 3x minus 5. We good to there so far? Oh yeah, I want to help you clean that up though. That's easy to mess up. How do you clean that thing up? We can't leave it that way, right? That's a complex fraction. This will come up a lot in calculus, so I could do you some long-term good here. And just reminding you how to clean up something like that. They do it all the time in calc. They assume you just know it like the back of your hand. So how do you do it? What do you do?
Multiply 5 by 3x over 3x.
Yeah, everything by that 3x. Yeah, everything. Right? Because that's the extra denominator causing the problem, right? So that's exactly right. Multiply everything by 3x. But you got to do top and bottom, equal treatment like always. Whenever you do something to the top fraction, you got to do it to the bottom. And so then what do we get? 21x on the top. On the bottom, these will cancel. 4 minus 15x. There we go. See how it's just a regular fraction now? It's not fractions within fractions anymore. It's not a complex fraction. That good? Questions on that one? All right. Okay, so how do we solve? So there has to be a special category in your mind or on your study sheet for the final there for greater than, less than. You have to recognize that that's different. There'll be two of these. Well, maybe one. I don't know, one or two. Probably just one. On the final. So what do you do when you see greater than, less than? Remember we did a special thing? These are the kind that we had to basically do the graph on. Remember that whole process? So when you have x squared or higher, or fractions, with greater than, less than, whatever, greater than, less than. So you have x squareds or fractions. So I'm saying higher powered things or fractions. Step one is get a 0, which we've already got it, and factor the other side. So we've got a 0. Let's factor. Now, do you know how to factor? What do you do first to factor this?
You would factor out an x.
Take out the GCF, which is x. Yeah. Leaves x squared minus 4 minus 45.
4x.
Thank you. 4x. Okay, and then a little further. Right, what two numbers multiply to be 45? 9 and 5. Sign in the middle goes on the bigger, huh? They got to add to be -4. So -9 plus 5 is -4. Okay, we good to there? Now, what I've seen over the years of teaching this class and ones like it in which we have these kind is the following mistake. So let me do it so you won't. So you can't now say, okay, x is greater than 0, x minus 9 is greater than 0, x plus 5 is greater than 0. That's that, and then just, finish it up. Greater than 9, greater than minus 5, greater than 0. There it is. Let me go find that answer. That's just not true. That's not true. Because a bunch of things are multiplying to be, you can't, I know why we think that, because that's what we would do if it was equal. That's right. If it was equals, that would be perfect. That would be exactly what we do. Now, why can't we do that for greater? Well, think about the logic. That's why it's always better in math and science to understand the logic than just the monkey just kind of imitating steps without really getting the thinking, because you'll make these kind of blunders. Why did that work for equals? Why would that be true for equals? Well, because if a bunch of things are timesing and they're coming out equal to 0, yeah, any of them could be 0. Right? If I told you I'm thinking of two numbers, they times and come out 0, well, either one could be 0, and they'll multiply and be 0. But that's not true. That logic doesn't fly for greater than 0. If I said, hey, I'm thinking of two numbers in my head. I'm thinking of two numbers in my head. I'm multiplying them, and they're coming out greater than 0. So what? That doesn't mean one of them's 0, right? In fact, one of them couldn't be 0. Couldn't. Now, you might think, well, that means they're both positive. Or what else could they be? Yeah, you see, we can't, and when you say greater than 0, you're basically saying positive, aren't you? We can't say that. They don't have to both be positive. They could both be negative. So the point is, it's complex, and you can't do that. You with me? Do you see how the logic isn't the same for greater than 0 than it is for equal 0? It's a different deal. So you got to specifically remember and put on your final sheet, when you see the greater than less than, you can't just do the normal thing where you just do that. Well, what do you do then? What do? You got to graph it. Remember, I said basically, can you just get the graph? Which is easier said than done. Let's get the graph. So how do we get the graph? Well, these points like x equals 0, x equals 9, and x equals negative 5, they are where the graph hits 0, aren't they? So right here at 0, right back here at negative 5, and right over here at 9, the graph will hit a height of 0. In other words, if this is y equals, and this is function equals, they will be a height of 0 there at those places. You tracking with me? That's where it'll be a height of 0. But beyond that, it'll be above or maybe below, or go like that. I don't know. I got to figure out what it's doing in between those spots. And in the end, I want where it's greater than 0, where it's above, which would be like here and here and in here. I don't know yet. Let me find out what the graph is doing. You understand the game plan? If we can just find the graph, then we can find out where it is above 0, where it is greater than 0. So I know it hits 0 at these three spots. That much is true. How do you figure out what it's doing in between those spots? You can either plug in, or you can use the in behavior bounce pass-through thinking. Either one. Both will work. You can just, look, I'm just going to plug in like 10. Sure, do that. Plug in 10. You'll find out whether it's positive or negative, above or below, right? Let's plug in 10. You can plug into the original, to this one, any of them, doesn't matter. So I'll just take the y equals x, x minus 9, x plus 5. That's what I'm trying to graph, is that function, right? And find out where that function is greater than 0. So plug in 10, 10, 10. What are you going to get? 10 times 1 times 15. That's positive, isn't it? So the graph must be up here. I don't know exactly what it's doing. All I care is it's above. And it's above everywhere out there. Notice it can't come down and cross again. Why not? Because there would be another place where it hits 0. And there's not. It only hits 0 at 0, at 9, and negative 5. It can't come down again. Can it? So you see what I know? I know it's got to be going up here. Now plug in something between 0 and 9, like 1. Plug it into x, x minus 9, x plus 5. Plug in 1, 1, 1. What do you get? 1 times minus 8 times 6. That's negative, isn't it? So that's down here. No surprise. Plug in something between 0 and negative 5, like negative 1. Plug it into x, x minus 9, x plus 5. Plug in 1, 1, 1. What What do you get? 1, negative 8, 6. That's negative again.
Yeah, but negative 1, not just 1.
Oh, thank you. I'm messing up. Man, I make a lot of mistakes today. So that's negative 1, not 1, and that really matters, doesn't it? That's negative 1, negative 10, 4. So 2 negatives, positive. So it actually goes up there. So it's going up, and then it comes back down. I know it has to hit back down here. Okay, and now what does it do over there? To the left, plug in something like, negative 6. And let's see what we get. Into x minus 9, x plus 5, negative 6, negative 6, negative 6. You're going to get negative 6 times negative 15 times negative 1. 3 negatives?
You get a negative.
Negative. All right, so there's the graph. You could have done the bounce pass-through thing also in behavior. Remember that? Remember in behavior? We could have said, in the end, I know it's positive because the front biggest term is positive. So you plug in millions and billions and trillions, that term's going to dominate and take it positive. So I knew it was positive in the end, and these are all pass-through points. It's not going to bounce at any of those points. It's going to pass through, pass through, pass through. How do you know? What makes something bounce?
Positive.
Even powers. Remember, so these have a 1 power, invisible 1 power, invisible 1 power. If any of those had a 2 power, it bounces at those places. Remember that? Because x squared bounces like a U shape. But odd powers like x cubed is a snake, it passes through. Remember all that? That's another way you could have done it. Anyway, let's answer this question finally. What is the answer to this question? They want me to tell them, where is it greater than 0, please? Here and here. Those are the places the graph is above 0, which is what? Between negative 5 and 0, united with 9 to infinity, huh?
Yeah, because it's not...
Oh, yeah. Parentheses, huh? Yeah, there's no equals bar there. You're all right. So it's parenthesis, 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 like that on everything. From minus 5 to 0 and from 9 to infinity. There is the answer. Let's see if that's there. Minus 5 to 0, 9 to infinity, yeah. We good? It's a long one, huh? All right. So what do? So when you have fractions with greater than, less than, whatever, step 1, get a 0, and make it one fraction by LCD. So jump this over. So we get 14 x minus 6 minus 12 over x minus 1 greater than 0. And now we have to make those two into one fraction by common denominator. So I'll multiply top and bottom of this one by x minus 1, top and bottom of this one by x minus 6. You multiply by the other denominator, top and bottom, to get common denominator. Okay, so what do I get? 14 x minus 1 minus 12 x minus 6 over x minus 6 x minus 1 greater than 0. Good there? You okay with all the common denominator stuff? And then distribute. 14x minus 14, boom, boom. Minus 12x plus 72 over x minus 6x minus 1 greater than 0. Bring it over here. Gather like terms. 14x minus 12x, 2x. 72 minus 14, is that 58?
Yes.
Over x minus 6, x minus 1, greater than 0. So, all right, that's all step 1. Get a 0 and make it one fraction. So now, what do we do from here? Yeah, you got to find what makes the numerator and the denominator 0. So that's step 2. So we got that copied down. I'm going to move to a fresh screen. Too good. So, okay, so this will be on YouTube if I'm moving too fast. 2x plus 58 over x minus 6x minus 1. Greater than 0. We good there? Everybody got that copy down? What you need to see there? Okay, so now step 2. Step 2, the top equals 0 and the denom equals 0. Whatever makes the top 0 and the bottom 0, those are going to be important pivotal points on the graph. So let's take the top equal to 0, just the top, and solve first off. Negative 58 divided by 2 minus 29. And then the denominator equal to 0. You can see that's 1 and 6, huh? So remember, when something makes the denominator 0, what is that on a graph? Undefined. And so what is that on the graph? Vertical asymptotes. Remember, whatever makes the denominator 0 are your vertical asymptotes. So that means when I go to the graph now, and I have one of these at 1, one of these at 6, one of these at like minus 29, there's actually going to be a vertical at 1 and 6 are vertical asymptotes, aren't they? Because those made the denominator 0. So on the graph, those are vertical asymptotes, whereas the negative 29, that's just a place where it hits 0, because that makes the top of the fraction 0. So then you just got to plug in points. Okay, if I just check out of this one now. So now you just got to plug in points, plug in something like 7, plug it into the original function back here. Plug in 7, plug in 7, plug in 7. See how you can just look at it real quick? It's going to be positive over positive times positive. It's going to be positive. See how I did that real quick? You'll do something like this in Calc 2 with derivative. I just plugged in 7. So I'm going to plug in something in each of these 4 sections. We have 4 sections, right? Section 1, Section 2, Section 3, Section 4. Between the different markers, right? 4 sections. I'm going to plug a number into each section and find out if it's positive above or negative below. That's all I need to know now. Is the graph above or below in each of those sections. So if you plug in 7, see, you can see right there, 2 times 7 is 14, add 58. It's positive. I don't care what the number is. It's positive. And the bottom, 7 minus 6, that's positive. 7 minus 1, that's positive. It's positive right over here. It's positive over positive times positive. It's positive. So that means the graph is up. It's a vertical, so I know it's going up like that, but it's above. What about in the middle section? What if I plug a number in to the middle section here? Like plug in something like 2. Come back over here, put in 2. Can we just look at it real quick? Put in 2, put in 2, put in 2. See, it's going to be positive over negative times positive. See that? 2 minus 1 is positive, right? So that's negative, isn't it? That's negative. So the graph is down here. Going next to both those vertical asymptotes, but it stays negative, doesn't it? It's negative in that zone. Now plug in something between negative 29 and positive 1. Like 0 or negative 1 or whatever you want. Negative 28. Those are all good. So I'll put in 0. So put in 0. Come back over here and put in 0. What are you going to get? 0, 0, 0. You're going to get positive over negative times negative. 2 negatives in the bottom? Positive. So this graph is up. So the graph is going up to that vertical, coming down and hitting 0 right there. I know it has to hit that 0, doesn't it? Because that makes the top 0. It's got to hit there. And then you could do the other side. It'll pass through. It'll go like that. You could plug in negative 30. If you plugged in negative 30, you would see that they're all 3 negative. Negative 30, negative 30, negative 30. 2 times negative 30 is negative 60. Plus 58 is negative over negative. Times negative. 3 negatives is negative. That's why it's down there. So now, final question. What do we want? The places above or the places below? Greater than 0. So where is that graph greater than 0? Here and here. So that's from negative 29 to 1 united with 6 to infinity. The graph is above. I kept saying I wasn't going to do that whole problem. I just kept going. So that's a long one. I better move on. That's on YouTube. I'm going to look back. If you look at the answers, see how they're all square completed? To see which one's right, we got to complete the square. So, all right, so that's a big pain. So you got to jump the 180 over, gather up the x squareds. So 3x squared minus 24x, 4y squared plus 48y. Push the 180 to the other side, becomes a negative 180. Remember that? Gather the x's together, the y's together, and push the numbers to the other side. What do we do next? Anybody remember this?
You have to factor anything we can out of the...
Yeah, factor the numbers in the front out. Take out that 3. X squared minus 8x. Can't have a number in the front. Got to leave a blank. Plus, factor out that 4. Leave a blank. Good. And now we got to find those numbers that go in the blanks, don't we? How do we find those numbers?
Completing the square.
Complete the square. Yeah, we got to complete the square. So take that minus 8. Remember what we do with the middle number? Over 2 squared. Remember that middle number over 2 squared. Just be a good one to put on your full sheet of notes for the final. So that'll be minus 4 squared plus 16. And then let's grab the... Oh, and when I add 16 to the left side... But it's not just 16, is it? By putting a 16 right there under the multiplication of 3, I really added 3 times 16, 48, to the right side as well. You have to add 3 times 16 to both sides. Remember that? That way you're really doing the same thing to both sides. Next, grab the y number in the middle. Put it over 2 and square it. 6 squared, 36. Add 36 to the left side and 4 times 36 to the right, because that 36 is under the multiplication of a 4. All this coming back. Remember this? These were not easy. All right, where does that leave us? So all of this becomes 3, and if you factor that, x minus 4 squared. Plus 4, and if you factor that, y plus 6 squared equals the other side. I don't know. Somebody got that?
Negative 192, 12, which came up to 12.
12. Thank you. It's a nice 12. What do we do now? We're almost there. Yeah, because you got to get a 1 on the right side. Remember the ellipse and hyperbola equations? You had to get a 1 on the right side. So divide through by 12. And then 3 goes into 12. 4 times 4 goes into 12 3 times. So we get x minus 4 squared over 4 plus y plus 6 squared over 3 equals 1. So there's the equation in its good form. Yeah, I'm wondering that too. Let's go see what the options have. X minus 4 squared over 4. I see that there and I see it there. Plus y plus 6 squared over 3. Yeah, so 2 of them, A and D, both have that. So we got to find the rest. What's the center? We only need one more thing. What's the center? Remember, it's opposite, opposite. Anytime numbers are right next to x and y, it's opposite, opposite. So that's going to be 4 minus 6, isn't it? Look back. Center, A's wrong. Minus 4, 6, no. A's out. The answer must be D. 4 minus 6, it's got the right formula. Well, except for the fact that the foci points might be wrong and the vertices might be wrong. Yeah, I'm out too. They're good. The answer's D. It is. You could prove it. You could go on, and I mean, we're almost out of time. That would use up pretty much. Well, I don't know. Would that be Maybe I better just do that. No, let me just do 39. What is the? It's a ellipse. Okay. So you want to put them on the graph, right? Let's put them on the graph. It's going to be okay. So maybe I should. I don't think there's going to be room, is there? So back 5. Okay. So if this is say this is back 5. One, 2, 3, 4, 5, 6, 7, 8, 9. No, there's not room. All right, I'm really running out of room here. I need a medium. Oh, that's weird looking. I need there. Here's what I need. All right, let's try it again. So I need medium. There we go. Okay, so let me try this again. All right, so let's put the information on there. So minus. So I'm going to draw a little graph. And put down what they're saying. Back 5, up 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, right there. So there's back 5, up 4, and then, right, this is back 5, and then 11, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 11, up 1, 2, 3, 4. So there's 11, 4. So there's the two vertices, and the focus is at 9, 4. Right there. Okay. So there's a picture of what they're talking about. It's an ellipse. So you know the general look. It's like an egg shape. Going like a big blimp. Going between the vertices. And they want me to come up with the equation. So first thing I need to do is find the center. How can I find the middle of this thing? Yeah, you got to take the negative 5 and the positive 11, right? The two vertice points, and average them. Middle is average, isn't it? So it's 5 plus, negative 5 plus positive 11 divided by 2, which is 6 over 2, which is 3. So right here at 3, and of course it's up 4 like everything is, over 3 up 4 must be the middle. Double check it. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, it's 8 from each side. That is the middle. See how I found that? I just took the two x coordinates, negative 5 and 11, negative 5 and 11, for the two vertices, added them and divided by 2. So the center then is 3, 4. So that's good. Now we're in business. So we can say the equation is x minus 3 squared plus y minus 4 squared over something which I don't know yet equals 1. Good so far? That's how the ellipse equations always go, opposite of the center numbers. So now I just got to find the a squared and the b squared, what goes below x and y. How do you find those? What are a and b? Distance from center. So A is the distance, right? A is distance center to edge. Remember that? So how far is it from over 3 to over 11? 8. So this must be 8 squared. Remember? It's underneath x, so it's right left. Right? Whatever's underneath x is right left. Now, what's underneath y is up down. How far is it from center up? I have no idea. I just sort of drew that. I don't have any points up there. I don't know. How am I going to find b? Yeah, Thomas, good. Good memory. The focus equation. Remember the focus equation? The focus equation, it's basically the Pythag, but remember how the signs go? You want to have all this on your study sheet. Whatever sign is in the main equation, plus for the ellipse, they have a positive relationship, right? Two branches that connect to make it 8. They have a positive, whereas the hyperbola has the negative relationship. They turn away from each other, right? So the ellipse has positive in the middle, which means negative in the focus. It's always opposite sign in the focus equation. So that's right. A squared minus b squared c squared. Plug in A. You know A is 8. We don't know B. What's C? C is distance center to focus. Yeah, how far from the center to the focus? How far from 3 to 9? 6. So 64 minus b squared is 36. We're almost there. 64 minus b squared is 36. Subtract the 64. Minus b squared is it 28? Yep, divide by -1. B squared's 28. So b is the root of 28. I'm just going to put b squared 28 and 8 squared. Well, I'll just leave it 8 squared. Did we get the equation? X minus 3 squared. There's a 28. Wait, these both have 28. Those. Oh, it's none of the above? Yeah. All right.